CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Class 7, Chapter 12, Earth, Moon and the Sun, page number 169. On the right-hand side, top corner, you can find a QR code. By scanning the QR code, you may access the resources related to the chapter. One morning in Kanyakumari, Tamil Nadu, 12-year-old Rashmika was eagerly cycling to school. She was excited. That was the day her science teacher had dedicated a class for students to share and try to explain interesting observations. Rashmika had been noticing that the coconut tree shadows were long in the morning but shorter in the afternoon on her way back. She thought about it and decided that the size of the shadows changed because the sun moved across the sky during the day. But she also remembered learning that the earth moved around the sun, so she was puzzled. In chapter Beyond Earth in the grade 6 science textbook Curiosity, she wondered, does the sun move in the sky or does the earth move? Just below the text is a beautiful picture with many coconut trees and 3 students dressed in school uniform cycling to their schools. Page number 170. Section 12.1, Rotation of the Earth. You might have also noticed that the sun rises in the east and sets in the west. Have you ever wondered why? Let us try to understand why. Have you ever enjoyed riding a merry-go-round at a park or at your school? Let us go back to riding a merry-go-round. Activity 12.1. Let us explore. Sit on a merry-go-round facing towards the outer side as given in figure 12.1. In the figure 12.1, a girl is sitting on a merry-go-round. She is observing objects around her while riding on a merry-go-round. I can also notice a boy holding the merry-go-round and trying to push it in the circular direction. Ask someone to turn the merry-go-round slowly in the anti-clockwise direction as given in figure 12.1. While you are sitting on the moving merry-go-round, look around you. Do the objects around to appear to be moving? In which direction do they appear to be moving? While you turn in the anti-clockwise direction, the objects appear to turn around you in the opposite direction, that is, in the clockwise direction. Now fix your gaze at a particular tree or a building ahead of you while sitting on the merry-go-round, turning around in anti-clockwise direction. In which direction do you find the tree turning around you? Is it in your view all the time? The tree appears to turn around you in the opposite direction, that is, the clockwise direction. The tree appears in your view from your left-hand side and then moves out of your view on the right-hand side when you view it from a merry-go-round turning around in anti-clockwise direction. Using the observations made by us while riding a merry-go-round, let us now think. When we view from the earth, the sun appears in the east, moves across the sky from the east to the west and disappears in the west. Does it indicate that the sun is moving in the sky? Or might it be that the earth itself is turning around and the sun just appears to move? The fact is that the sun appears to be moving because we view it from the earth, which is turning around itself. Page number 171. In which way is the earth turning around itself? To visualize this, let us recall some of the objects which turn around themselves. Have you noticed a top spinning around its spindle? Figure 12.2a. Or a spinning fan? Figure 12.2b. Or tried spinning a ball? Figure 12.2c. there are three pictures in figure 12.2. A is a spinning top, B is a spinning fan, and C is a spinning ball. In a similar manner, the Earth also spins or rotates on its own axis in space as given in figure 12.3. On the right-hand corner, there is the figure 12.3, which is illustrating the rotation of the Earth, showing the axis. On the top, it's mentioned Earth's axis of rotation. The North Pole and the South Pole are marked at the top and the bottom of this picture respectively. It is the picture of a globe. The upper half of the picture is marked as Northern Hemisphere. There is a line in the center. On the left-hand side of the line, West is mentioned, and on the right-hand side of this line, East is mentioned. This line is named as the equator, and below it is the Southern Hemisphere. The Earth's axis of rotation passes through its geographic North Pole and the South Pole. The Earth completes one rotation in about 24 hours. When viewed from the top of the North Pole, figure 12.3, the Earth is rotating in the anti-clockwise direction, that is, from west to east. Let us try to understand this with the help of a globe. You have used a globe in class 6 to represent the Earth and identified North Pole, South Pole, and equator on it. You also learned that its axis passed through its north and south poles in the grade 6 social science textbook Exploring Society, India and Beyond. Activity 12.2. Let us explore. Use a globe to represent the Earth and place a small sticker to mark your location on it. Figure 12.4a. In the figure 12.4a, there are two students in school uniform. They are standing behind a table. On the top of the table, a globe is kept. A sticker is marked on the top of the globe. Arrows are shown from west to east to indicate the movement or a rotation of Earth. Figure 12.4a, using a globe to understand rotation of Earth. While viewing from above the North Pole, slowly rotate the globe on its axis in anti-clockwise direction. Observe how your location turns around and finally comes back to its original position, completing one rotation. Let's dive deeper. Rotation is the motion of an object in which all its parts move in circles around an imaginary line that passes through it. This line is called the axis of rotation. Page number 172. On the left-hand side top corner, a girl is saying, "Let us now further explore to understand how day and night occur on the Earth due to its rotation. Use a torch to represent the sun. Go to a relatively dark room to carry out further steps of the activity. Now shine light from the torch placed at some distance, say 1.5 meters, on the globe as given in figure 12.4b. Do you notice how half of the globe receives the light from the torch while the other half stays dark? It is daytime in that half of the globe which receives light and night time in the other half. Right next to this point on the left side is figure 12.4b. It illustrates a table. On top of the table, a globe is kept. On the left-hand side of the globe, the torchlight is throwing light on one half of the globe. The caption reads, "Using a globe and a torchlight to understand day and night." In India, Sunrise first occurs in the eastern part and then in other parts. While looking at the eastern part of India on the globe, rotate the globe in one direction and then in the opposite direction. What is the direction of rotation when light falls on the eastern part of India first? The light falls on the eastern part of India first when the globe rotates from west to east with respect to the north-south axis of the globe. Now, while rotating the globe from west to east, observe your location on the earth. Does it go through a cycle of day and night? Sunrise occurs as your location moves into light, and sunset occurs as it moves into darkness. The earth's rotation from west to east causes the day-night cycle. As given in figure 12.5, the side facing the sun experiences daytime, while the other side is dark and experiences night. Just below the text, figure 12.5 is given with the caption, "Sunlight falls on half of the Earth's surface." Figure 12.5 shows a globe representing Earth. Sunlight is falling on the left side of the globe, illuminating the half which is facing the sunlight. The other half of the globe is in darkness. It also shows the Earth's axis of rotation and marks North Pole as NP. Page number 173. Now imagine that you are standing on the equator on the earth and watching the sky during one rotation of the earth while it rotates from west to east. What will you observe? Will your observation be the same as that of the girl shown in figure 12.6? Just below the text is a picture, figure 12.6, with a caption, "A girl on the rotating earth viewing the sun from the equator." Figure 12.6. The girl on a rotating earth viewing the sun from the equator. The picture shows a globe representing Earth. Right at the center, North Pole is indicated. There is an arrow going from left to right. A girl's picture standing vertically on the spherical surface of the earth towards right. The caption number 1 reads, "I am facing north and my back is to the south. The morning sun appears in my view to my right in the east." A girl's picture standing vertically on the spherical surface of the earth upright. Caption 2 reads, "Around noon I have rotated to a new position where the sun is now over my head." The picture indicates sun right above the head of the girl. Girl's picture standing vertically on the spherical surface of the earth towards left. Caption 3. "By evening, I have rotated further. The sun has started to disappear from my view to the left from the west. The stars will now become visible in the night sky." Due to the rotation of the earth, the sun appears to rise in the eastward direction, move across the sky from the east to the west, and set in the westward direction, figure 12.6. Then the night begins and the stars become visible in the sky. Fascinating facts. In the earlier chapter, Measurement of Time and Motion, you learnt how the scientist Galileo discovered an important property of a pendulum, and in the 17th century, another scientist, Huygens, used that property to make pendulum clocks that measured time. In the middle of the 19th century, another scientist, Leo Foucault, used a long pendulum to give the first demonstration of the Earth's rotation. The pendulum, known as a Foucault pendulum, in his honor, consists of a long string with a heavy bob suspended from a high ceiling. The Foucault pendulum, with a length of 22 meters, has been hung from a skylight in the Constitution Hall of the new Parliament building in New Delhi, India. It symbolizes the integration of the idea of India with the vastness of the cosmos. On the right of this fascinating fact is the picture of the Foucault pendulum. Page number 174. Since the earth is rotating, shouldn't the stars also appear to move in the sky like the sun? Is a question asked by a boy. Yes, indeed. Let us look at the stars in the night sky to see the effect of Earth's rotation. Activity 12.3. Let us explore. On an early evening between March and May, identify the Big Dipper, Saptarishi, and the pole star, Dhruv Tara, if visible, as you did in the chapter Beyond Earth in Grade 6 Science textbook Curiosity. Note down your location and date of your night sky observations. The activity must be carried out on the same night. Draw the orientation of the Big Dipper in the sky with respect to the pole star or a fixed tree, building on the ground in a direction towards the Big Dipper if you cannot see the pole star. Mark the time of your observation along with your sketch as given in figure 12.7. On the left-hand side of the page is figure 12.7 with a caption, Illustrative Sketch of Big Dipper for Activity 12.3 by a student located in Pune on the night of 1st and 2nd April. The picture demonstrates how the position of Big Dipper changes at 7 p.m., 9 p.m., 11 p.m., 1 a.m., 3 a.m., and 5 a.m. The directions are also given in the picture. On the left side is the northwest direction, in the center, north, and on the right side it is the northeast direction. After 2 hours, observe the Big Dipper again. Has it moved? Again, draw its orientation and note the time. Repeat the above step after 2 hours. Do you observe that the Big Dipper appears to move around the pole star? Notice just the movement even if you cannot see the pole star. The Earth's axis of rotation points very close to the pole star in the northern hemisphere. Therefore, the pole star appears nearly stationary in the sky from the Earth. All the stars appear to move around it. Just like the sun, the moon also appears to rise in the eastward direction and set in the westward direction because the Earth rotates from west to east. Fascinating facts. Astrophotographers take long exposure photographs, keeping the camera's shutter open for a long time. In such a photograph, the apparent motion of the stars is recorded as arcs of a circle known as star trails. On the left of this fascinating fact is a picture taken from Mahuli, Maharashtra, which shows the apparent motion of the stars recorded as arcs of a circle. Page 175. Fascinating facts. Ancient Indian astronomers, including Aryabhatta, had also noticed the daily apparent motion of the celestial objects such as the sun, moon, planets, and stars. Aryabhatta was a famous mathematician and astronomer of ancient India who wrote an important treatise, Aryabhatiya, around the 5th century CE. The apparent motion of the stars due to the rotation of the earth is explained in verse 9, Golapada Aryabhatiya. Just as a man in a boat moving forward sees stationary objects as moving backwards, so also the stars that are stationary are seen by people of Lanka as moving towards the west. Aryabhatta's stated value for the time taken by the earth to complete one full rotation about its axis is around 23 hours, 56 minutes, 4.1 seconds in modern units. This value is impressively close to the currently accepted value. I have seen that the stars and constellations that appear in the east at sunset change during different months. This is a question by a girl. The boy answers, yes, maybe that is why we were told to look for certain stars and constellations at certain times of the year in grade 6. But why do different stars appear in the night sky over the course of a year? 12.2 Revolution of the Earth. While rotating on its own axis, the Earth also revolves around the Sun, as we learnt in grade 6. This movement is different from rotation. Revolution is the motion of an object around another object. Page 176. The path an object takes while revolving around another object is called its orbit. If viewed from the top, figure 12.8, the orbit of the Earth around the Sun is nearly circular. In the figure of the solar system given in the chapter Beyond Earth in the grade 6 science textbook Curiosity, the orbit appeared elongated because it was a side view of the orbit. The Earth completes one revolution around the Sun in about 365 days and 6 hours. 12.2.1 Changing view of night sky from the Earth. Every evening the sun sets in the westward direction and the night sky becomes visible. We know that this occurs due to Earth's rotation. As the Earth also revolves around the Sun continuously, the stars seen in the night sky after sunset gradually change over a year as we look in different directions, as given in figure 12.8. Below the text is the figure 12.8 with the caption, Revolution of the Earth around the Sun leads to changing view of the night sky throughout the year. The sizes and distances are not to scale. The picture shows Sun in the center and the Earth revolving around the Sun. There are 4 pictures of Earth. On the left-hand side, June is indicated. Half of the Earth is dark and the part of the Earth towards the Sun is lit. It also has a caption, Stars that rise at sunset, and just below this is another caption which reads, Stars that set at sunrise. Below the Sun indicates the month of September. The part of the Earth, which is the upper part, is now lit by sun. The lower part is showing complete darkness. Towards the right is another picture of Earth. The left part of this picture is lit because of the presence of sun in its left. The right side of this picture of Earth is dark. Just below this picture of Earth, there is a caption which reads, Different stars rise at sunset in different months. The 4th picture of the Earth is just above the picture of the Sun. The lower part of the globe is lit and is showing complete light, whereas the upper part of the globe or the picture is in complete darkness. It is indicating the month of March. You can also notice this change by looking at the pattern of stars, such as those that you learnt about in grade 6, at a fixed time of the night on days separated by a month. Fascinating facts. The Bhil and Pawara are indigenous communities from the Tapi Valley in western India who use the appearance of certain patterns of stars in the sky as markers for the arrival of monsoon rain. Page 177. 12.2.2 Seasons on the Earth. I have noticed that we go through a cycle of seasons every year. Is it related to the revolution of the Earth around the Sun in some way? A boy is asking. The girl replies, I have also noticed that days are longer in summer than in winter. The Earth's axis of rotation is not upright with respect to the orbit but is tilted. The Earth maintains this tilt as it orbits around the Sun, figure 12.9. The tilt of the Earth's axis and the spherical shape of the Earth gives rise to seasons. Let us find out how. Below this text is figure 12.9. The caption of the figure is different positions of the Earth while revolving around the Sun. The Earth's orbit appears elongated because this is a side view and not the top view. The sizes and distances are not to scale. The figure indicates Sun in the center, and there is the orbit of the Earth showing 4 positions at different times of the year. On the right-hand side, it is December with the caption Winter in Northern Hemisphere. The part of Earth towards the Sun is lit, while the other part is in darkness. The second picture of the globe that is representing Earth is above the Sun, indicating the month of March. On the left-hand side, the picture of Earth, that is the globe, indicates the month of June. The part of globe towards the Sun is lit and the other half is in complete darkness. The caption reads, Summer in Northern Hemisphere. The lowest part of the figure indicates the month of September. The upper part exposed to the Sun is lit, while the rest of the part is in darkness. In June, the Northern Hemisphere is tilted towards the Sun, while the Southern Hemisphere is tilted away from the Sun, figure 12.9. As observed in figure 12.10a, as observed in figure 12.10a, a given amount of sun rays are spread in a smaller area in the Northern Hemisphere as compared to the Southern Hemisphere due to the spherical shape of the Earth's surface. So that area is heated more. Further, the Northern Hemisphere receives sunlight for more than 12 hours in June. Figure 12.11a. So the Northern Hemisphere experiences more intense sunlight which lasts for a longer time, causing the summer season. In December, this situation is opposite in the Northern Hemisphere, and in December, this situation is opposite in the Northern Hemisphere, and it experiences winter season with sunlight for shorter time. Figure 12.10b and figure 12.11b. Page number 178. Figure 12.10a. More intense sunlight is indicated in the Northern Hemisphere and less intense sunlight in the Southern Hemisphere in June. Some amount of sun rays are spread in smaller area in this hemisphere, hence are more intense. Figure 12.10b. The opposite situation happens in December. Same amount of sun rays are spread in a larger area in this hemisphere, hence are less intense. Figure 12.11. In the Northern Hemisphere, in the figure A, longer daytime in June. The figure also indicates the North Pole, which receives sunlight for all 24 hours in June. Places in the hemisphere receive sunlight for more than 12 hours during the 24-hour rotation of the Earth. Figure 12.11b. Shorter daytime in December. Places in this hemisphere are in darkness for more than 12 hours during the 24-hour rotation of the Earth. The figure also indicates that the North Pole is in darkness for all 24 hours in December. The seasons and length of daytime are reversed in the Southern Hemisphere as compared to the Northern Hemisphere. There it is winter in June and summer in December, figure 12.10 and figure 12.11. Dive deeper. Two incorrect reasons often given to explain why seasons occur on the earth are: when the northern hemisphere tilts towards the sun, it is closer to the sun. The orbit of the earth is an oval with the sun slightly displaced from its center, so the earth is at different distances from the sun over the year. However, the difference in distances in either of these cases is very small, and these are not the reasons why seasons occur on the earth. In fact, the earth is closest to the sun in January. Page 179, dive deeper. In the northern hemisphere, the longest day occurs around 21st June. This is known as summer solstice. After the summer solstice, the duration of the day becomes shorter, while that of a night becomes longer. The shortest day and longest night in this hemisphere occur around 22nd December, known as the winter solstice. Around 21st March and 23rd September, the daytime lasts for 12 hours. In the northern hemisphere, these days are called spring and the autumn equinox respectively. Fascinating facts. At the North Pole, the sun rises in the east direction on the equinox day, 21st March, and remains continuously in the sky for 6 months. The sun sets on 22nd September. The South Pole experiences the opposite behavior. The polar regions thus experience continuous sunshine for 6 months, followed by a 6-month period of darkness. On the equator, there is always 12 hours of sunlight and 12 hours of darkness. There is little difference in the intensity of the sun rays falling on the equator in different months. Thus, for the southern states of India that lie close to the equator, the effect of seasons is not very prominent. Other effects, such as local geographical features and proximity to oceans or seas, can also influence these broader patterns seen in the two hemispheres, as you have learned in social science. 12.3. Eclipses. Day and night cycle. Seasons. The life on the earth. So much is dependent upon the sun. Could the light from the sun get blocked by the two planets which are revolving between Earth and sun? A question is asked by a girl. The planets, Mercury and Venus, appear very small compared to the sun and never block the entire sunlight from the sun reaching us. However, you may be surprised to know that the moon can do that. Do you remember studying in grade 6 that the moon is a natural satellite of Earth and it revolves around Earth as the Earth revolves around the sun? Page number 180. 12.3.1 Solar eclipse. At certain times, the moon can come in between the sun and the earth in a way that obstructs the light from the sun from reaching us. This is known as solar eclipse. You may wonder how the moon, which is smaller than the sun, blocks the light coming from the sun that we see in the sky. Activity 12.4. Let us explore. Ask your friend to stand in front of you at a distance of about 5 meters. Consider his head to be the sun. Now close one eye and show a thumbs up with your outstretched hand towards your friend as given in figure 12.12. Are you able to cover the entire head of your friend with your thumb? On the left side of the page is figure 12.12, where it is indicated how a girl is outstretching her thumb and is trying to cover a friend's head. You can cover the entire head of your friend with the help of your thumb. Even your thumb is much smaller than the actual size of your friend's head. How could it be? The size of any object as seen by your eye, also known as apparent size, depends upon both its actual physical size and its distance from you. The thumb being much closer to you as compared to your friend, the apparent sizes of your thumb and your friend's head, as seen by you in activity 12.4, are similar. The apparent sizes of the moon and the sun in the sky are similar when viewed from the earth. This is so because though the moon is much smaller in physical size than the sun, the moon is much closer to us as compared to the sun. Therefore, the moon can appear to cover the entire sun as viewed from the earth. Dive deeper. Though the planets Mercury and Venus are much larger than the moon in size, they are also much farther from the earth as compared to the moon. Thus, their apparent sizes are very much smaller than the sun and they cannot block the sun. For example, when Venus passes between the sun and the earth, it appears as a tiny black dot passing against the bright face of the sun. This event, known as a transit of Venus, is a rare event. Figure 12.13 shows the arrangement of the sun, the moon, and the earth during a solar eclipse. The shadow of the moon falls on a small area on the surface of the earth as given in figure 12.13. This area is in total darkness and no part of the sun can be seen from there. The observers in this area witness a total solar eclipse, figure 12.14a. Page 181, figure 12.13, geometry of a solar eclipse. The sizes and distances are not to scale. The figure shows the sun on the left-hand side, the earth on the right-hand side, and moon in the center. Moon's orbit is shown around the earth. Earth's orbit is also indicated around the sun. Moon's shadow is falling on the earth and is indicated as total solar eclipse. There is a region which is indicated by lighter darkness, and that is indicated as partial solar eclipse. In areas where the moon partially blocks out only some regions of the sun, the observers see a partial solar eclipse, figure 12.13 and figure 12.14b. On the right-hand side, figure 12.14, solar eclipse, figure 12.14a indicates a total solar eclipse. Figure 12.14b indicates a partial solar eclipse. Figure 12.14c indicates a diamond ring seen after a total solar eclipse just when the moon starts to move away. During a total solar eclipse for a few minutes, it turns dark during the day as no sunlight reaches the earth. Due to the earth's rotation and the motion of the moon in its orbit, the moon's shadow moves across the surface of the earth. Thus, the total solar eclipse is visible only for a few minutes. As the moon begins to move away from the front of the sun, figure 12.14c, we see a partial solar eclipse and daylight begins to return. Safe viewing of a solar eclipse. Caution: during a solar eclipse, one might be tempted to look at the sun, thinking that it won't be strong enough to cause harm to our eyes. However, even during the eclipse, the sun is intense enough to damage the eyes and cause blindness. Thus, directly viewing solar eclipse must be strictly avoided. Also, do not view it through sunglasses, binoculars, or telescopes. Usually, astronomy organizations such as planetaria and astronomy clubs hold eclipse viewing events during a solar eclipse. Figure 12.15. Participating in such events is the best way to observe a solar eclipse, since the organizers not only provide specialized eye protection for solar viewing but also offer scientific explanations. In the bottom corner of the page, figure 12.15 indicates a public solar eclipse viewing organized in Ooty, Tamil Nadu. Page 182. Dive deeper. This activity, similar to activity 11.5, is to be set up by your teacher. A mirror can be used to project an image of the sun onto a wall. However, holding it at a correct angle throughout a solar eclipse can be difficult. To solve this, make a movable stand for the mirror. Use a hollow ball with a small hole. Half fill it with sand to keep it stable and attach a small mirror, such as an embroidery mirror, to it. Place the ball on a circular ring like an adhesive tape ring so it can be turned around easily. Adjust it until the sun's image appears on a wall or a screen. Figure 12.15 indicates this setup where the mirror is fixed to a green ball. Caution: this activity should be performed strictly under the supervision of a teacher. Take care not to direct the reflected light beam in anyone's eyes. People have observed eclipses and maintained records since ancient times. When the reasons for eclipses were not known, they feared the occurrence of eclipses. As you can imagine, something blocking the sun, the main source of heat and light on the earth, even for a brief period of time, would have been extremely concerning. Many superstitions were attached to solar eclipses in various parts of the world related to the activities that could not be carried during solar eclipses, such as eating, cooking, or going out of home. But now that we know the reason why a solar eclipse occurs, we need not fear these events as long as we do not look at the sun directly. In fact, scientists go around the world to observe the eclipses from wherever these are observable. The eclipses provide them an opportunity to study phenomena that cannot be observed otherwise. Fascinating facts. An eclipse is known as Grahan in Sanskrit and in many Indian languages. Many ancient astronomical texts provide calculations to predict eclipses. The best known and most referred text is the Surya Siddhanta, which is written in the classical Sanskrit poetry tradition in rhythmic shlokas. 12.3.2 Lunar Eclipse. As the moon revolves around the earth, sometimes the earth can block the sunlight from reaching the moon. This is known as a lunar eclipse. On such days, we see the earth's shadow falling on the full disk of the moon. Figure 12.16 indicates the arrangement of the sun, the earth, and the moon during a lunar eclipse. Page 183. Figure 12.16 Geometry of lunar eclipse. Sun is in the left, moon is in the right, earth is placed between sun and the moon, such that earth's shadow falls on moon, indicating total lunar eclipse. In the same figure, partial lunar eclipse is indicated, where earth's shadow is not falling on the moon completely but partially. The figure also indicates Earth's orbit around the sun and moon's orbit around the earth. The sizes and distances are not to scale in the figure. When the moon is completely in the earth's shadow, it is called a total lunar eclipse. The bright disk of the moon starts to appear dark red in color and stays that way until the moon moves out of the shadow of the earth. When part of the moon is in the earth's shadow and the rest of the moon is visible, it is called a partial lunar eclipse. Unlike the sun, we can safely watch the eclipsed full moon with our naked eye. Science and Society. Using the computer version of Stellarium app, which is free, you may get information about the upcoming solar and lunar eclipses, if any, which may be visible from your location. Fascinating facts. The Kodaikanal Solar Observatory is located in the beautiful Palani range of hills in southern India. It was established in 1899 and has provided data about the sun for over 100 years. It is operated by the Indian Institute of Astrophysics, Bengaluru. The picture of Kodaikanal Solar Observatory is also given along with the fascinating facts. Page number 184. Know a scientist. M.K. Venu Bapu is known as the father of modern Indian astronomy. He led efforts in setting up many instruments and telescopes in India, such as the telescopes at Manora Peak near Nainital, Uttarakhand, and Kavalur, Tamil Nadu. The observatory at Kavalur has been named after him. He mainly studied stars and even discovered a comet. He also travelled to different parts of the world to study solar eclipses. His picture is given on the left. In a nutshell, The Earth rotates on its own axis in about 24 hours. The Earth's rotation from west to east causes day and night, as well as the apparent motion of the sun, the moon, and the stars. The Earth revolves around the sun and takes nearly 1 year to complete a revolution. The Earth's axis of rotation is not upright with respect to the orbit, but is tilted. Seasons occur because of the tilt of the Earth's axis of rotation and its spherical shape. A solar eclipse occurs when the moon is in the path of the sun as seen from the Earth and sunlight is blocked from reaching the Earth. A lunar eclipse occurs when the Earth comes in between the sun and the moon, blocking sunlight from reaching the moon. Let us enhance our learning. In figure 12.17, how many hours of sunlight do the North Pole and the South Pole receive during one rotation of the Earth? Figure 12.17 indicates Earth as a globe. North Pole and South Pole are indicated, as well as the tilted axis. Number 2. Fill in the blanks. Part 1. Stars rise in the blank space and set in the blank space. Question number 2, part 2. Day and night are caused by the Earth's blank space. Question number 2, part 3. When the moon fully covers the sun from our view, it is called a blank space solar eclipse. Page number 185. Question number 3. State whether true or false. 3. Part 1. Lunar eclipse occurs when the sun comes between the Earth and the moon. 3. Part 2. Sunrise happens earlier in Gujarat than in Jharkhand. 3. Part 3. In Chennai, the longest day occurs on the summer solstice. 3. Part 4. We should watch the solar eclipse directly with our naked eye. 3. Part 5. Seasons occur due to the tilt of Earth's axis of rotation and its spherical shape. 3. Part 6. The Earth's revolution around the sun causes day and night. Question number 4. Padma Shri saw the Orion constellation nearly overhead at 8 p.m. yesterday. When will she see Orion overhead today? Question number 5. Nandini saw a group of stars rising at midnight on 21st June. When will she see the same group of stars rising at midnight next year? Question number 6. Abhay noticed that when it was daytime in India, his uncle, who was in the United States of America, was generally sleeping as it was nighttime there. What is the reason behind this difference? Question number 7. 4 friends used the following ways to see the solar eclipse. Who among them was being careless? Ravi Kiran used a solar eclipse goggle. Jyoti used a mirror to protect the sun's image. Aditya saw the sun directly with his eyes. Aruna attended a program arranged by a planetarium. Question number 8. Fill the circles in figure 12.18 appropriately with one of the following: Sun, Moon, Earth. Figure 12.18 has 6 circles. 3 circles are given in the first row with the heading Solar Eclipse. In the left circle, Sun is indicated. The other 2 circles are blank. In the second row, Lunar Eclipse is indicated. The first 2 circles are left blank. In the third circle, Moon is indicated. Page number 186. Question number 9. The moon is much smaller than the sun, yet it can block the sun completely from our view during a total solar eclipse. Why is it possible? Question number 10. The Indian cricket team matches in Australia are often held in December. Should they pack winter or summer clothes for their trip? Question number 11. Why do you think lunar eclipses can be seen from a large part of the earth when they happen, but total solar eclipse can be seen by only a small part of the earth? Question number 12. If the Earth's axis were not tilted with respect to the axis of revolution, explain what would be the effect on seasons. Exploratory projects. Repeat activity 12.2 but replace the torch with an electric lamp. Then place the globe at different positions on a circle around the lamp while maintaining the tilt of the globe. Part 1. Note down your observations regarding how much of the northern and southern hemispheres of the globe are illuminated at different positions. Part number 2. Rotate the globe and take a note of the length of the day and night on the different parts of the globe. Part number 3. Repeat part number 2 for different positions of globe on the circle. The Earth goes around the Sun in an oval-shaped path. Draw two circles with the same center, one with radius 14.7 cm and another one with a radius of 15.2 cm. If 1 centimeter corresponds to 10 million kilometers, the two circles represent the closest and farthest distances from the Sun. Note how small is the difference between two distances. Suppose the tilt of the Earth's axis of rotation increases. Will it cause more extreme seasons? Find out if the tilt of Uranus is more than the Earth and about the seasons there. Write an interesting article for a newspaper or your school magazine about it. Dive deeper. In reality, the planets move around a special point in the solar system which is very close to the Sun but not exactly at its center. The Sun also moves around the same point a little instead of staying perfectly still. Scientists use such tiny wobbles in the movement of other stars to discover exoplanets around them. Page 187. It's still not the end, my friend. And once again, we have reached the last page of this book. And as we said earlier, it is certainly not the end of our curiosity, our jigyasa. We hope you have enjoyed the activities and experiments as you journeyed through the chapters. More importantly, we hope you asked a lot of questions. Now it is our time to ask you one. Have you observed closely the front and the back covers of this science textbook? At first, they may just appear like regular scenes from a playground or a running track. But if you observe carefully, you will find tiny hidden science clues connected to the different chapters in the book. Observe closely. Maybe you will spot something related to what we discussed about motion or light, or maybe even about plants and animals. Challenge yourself to find as many science links with the chapters as you can. We think there are more than 25. And who knows, you might find connections that the authors and illustrators hadn't even thought about. That is exactly how discoveries in science were made, by someone just observing something new, something unusual in the world around them. This textbook is just a small guide, a map to find our way around the different parts of science. Never stop asking questions, and remember, your curiosity is the spark that lights the flame of exploration that will take you to incredible heights. And we'll join you again next year for more adventures in science. The picture on this page indicates a space station and a satellite being launched by our country into the sky. Page 188, Notes. Some blank spaces are given here for you to write down your thoughts and reflections. Chapter 12 ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration, Ritika Anand. Sound recordist, Virendra Rawat. Production assistant, Mohammad Shamim Khan. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.